Today, we'll look at how Lacework can secure your build. Specifically, we'll look at how you can integrate Lacework into the build process to improve visibility and gain valuable insights with actionable outcomes. Lacework Infrastructure as Code security integrates with your existing Git repositories to scan your IAC code for compliance violations. We get started with a single click. We go to the IAC security page where we choose our Git provider, in this case, GitHub. I click my organization, select all repositories, and click Install and Authorize. The IAC bot is now integrated into my repositories and will complete automated scans. I can click here to see the results of the first integration. Let's choose a repository and look at the findings for that repository. On the left-hand side, we can see the policy name, the severity, and the line of code that was in violation. Click to see the summary and guidelines for remediation. In some cases, the IAC bot suggests a fix for you. If we choose the Auto Fix Available feature, we can see all of those here. If I were to click on the Fix Now button, I can open a PR inside my Git repository with the suggested change. Here's an example of an AutoFix PR raised by Lacework IAC Security, where we can see details on the policy that was in violation and what the suggested fixes are. From here, we can choose to commit the change, which remediates the compliance violation. Now we are going to see how we can prevent vulnerable container images from reaching production. In the Lacework console, we click Settings and Container Registries. Clicking the Add New shows all of the container registry types we can integrate with. To catch these violations during the build process, we can use the inline scanner. To configure the inline scanner, we click Next. Now for each inline scanner I configure, I'll be given a unique token. At the top, we just give it a friendly name and open up the optional settings. We can see here limited number of scans per hour, the identifier tag, and the CI/CD policy that's associated with the token. Here we are in my GitHub repository. I'm using GitHub Actions for this example, and I've already integrated the inline scanner. So let's take a look at how I've done that. My main workflow is called deploy.yaml, and there are a bunch of jobs here that are dependent on one another. Essentially, they operate in order. I'll do a build of my image, then an inline scan, and if that's successful, I can do a deploy to dev, prod, or stage, depending on how that workflow goes. I'm calling this secondary Lacework vuln check so I can separate out what we're focused on today. I've passed a couple of parameters here, where my image is, what the image name is, and the image tag. Let's open up that secondary workflow so we can have a look. We're running the inline scanner as a Docker container, and we're passing it some options. We're asking it to mount a volume for the working directory, and we're passing it some variables that define our access token and our account name, so we can integrate our inline scanner back up to the Lacework console. You remember that we configured a policy here to block uncritical CVEs. As a final step, I run the inline scanner to evaluate my image. I specify that the scanner should fail on exit, save the results to the console, ensure that I'm using the policy from the console, and tag this execution with CI build and the build ID so I can trace it from my GitHub action back to the Lacework console. Here's an example of my pipeline failing when the inline scanner finds a vulnerability. As we can see here, the Lacework inline scanner job has failed, and it's prevented me from deploying to staging, dev, and production. If we dig in, we can see the details of the Lacework scanner. And in fact, if we scroll to the top here, we can see that 2 critical vulnerabilities were found that were also fixable, which meets our policy. And at the very bottom, we can see our policy is even referenced in the output. Now, if I wanted to trace this back to the Lacework console, I would find the build ID that we tagged, which is 263.662.9058, and take that to the console. And in the Lacework console, we go to Vulnerabilities, Containers, and in our filters, we find Build ID. We enter our matching build ID and hit Enter. We can see here that the results of the scan are captured. At this point, we've seen the process from start to finish. Our pipeline failed, our pipeline did what our policy said, and the results were returned to the Lacework console. We have full traceability end to end, and we're preventing vulnerable images from getting into our production environment. And that's a brief overview of some ways Lacework can secure your build. With these features and our integration into the Kubernetes admission controller, which is your last line of defense before an image reaches your production cluster, you can make sure that your code is secure before it's deployed, saving you time and money. Thank you for taking the time. Contact us to hear more about how Lacework can secure your cloud environment from build to runtime.